This lesson is on the distance formula. The leading question here is, how do we find the distance between two given points? So let's consider two given points. Point P, located at, say, x1, y1, and point Q, somewhere else, say, located at x2, y2. Which means the direct line that connects these 2 points is what we are looking for. Now, recall that this line can be viewed as having its horizontal and its vertical components, which make, then, a right-angled triangle. How do we find the distance of the horizontal and vertical components of this diagonal line? Well, if you were looking at these as coordinates, this is at 3 and this is at 8. 8 minus 3 is 5, which is the distance shown here. So in general, if you take the x values and subtract them, you're going to get the horizontal component. Similarly, if you take the y values and subtract them, you'll get the length of the vertical component. So, if we use the Pythagorean Theorem, we can find our missing side, d. Let's go ahead and use the Pythagorean Theorem. We know that the two shorter sides squared and added together should be the diagonal squared. So, if we solve that so that we have d by itself, a distance formula, that would mean we'd have to square root both sides, giving us d to be the root of x2 minus x1 squared and y2 minus y1 squared, which is the distance formula. Hopefully you can see where it's coming from. Let's now use this distance formula to our advantage. So say you're given 2 points A and B as given, 1, -2 and 3, 2. And you want to find the distance between A and B, you can go ahead and use the distance formula. You can label your points x1, y1 for point 1, x2, y2 for point 2, and you want to take your x values, subtract them in the same order, and the y values, subtract them in the same order, square them and add them, and then root the answer. So, let's go ahead and do that. 3 minus 1 for the x components, 2 minus -2 for the y components. That leaves us with a root of the square of 2 plus the square of 4, which is root 4 plus 16, which is root 20. Root 20 could be simplified into 2 times 10, which is 2 times 5. So a pair of 2's come out, and you're left with 2 root 5. Or you could give the decimal approximation of root 20 using your calculator, which gives you approximately 4.5 units for the distance. Great. Now, recall, how do we find the midpoint between 2 points? Remember, the midpoint is really the average of your x's for your x value and the average of your y's for the y value. So let's try that. The midpoint of A and B is going to be 1 plus 3 over 2, -2 plus 2 over 2, giving us 4 over 2 and 0 over 2, which gives us 2, 0. So this is now point M, the midpoint. If you imagine A and B somewhere, M is the point directly in between those 2 points. So now they're asking us to find the distance between A and M. Notice that the distance between A and M should be half of the distance between A and B. So approximately half of 4.5, which is 2.23. Let's see if this works. So let's find the distance for the distance formula between 1, -2 and 2, 0. So you want the difference between your x's, 2 minus 1, and the difference between your y's, 0 minus -2, giving you 1 squared plus 2 squared, which is root of 1 plus 4, which is root of 5, which is approximately 2.23. Notice that you didn't even have to approximate. You had 2 root 5 here, and you had root 5 here. So that means one of these is root 5, and together it makes 2 root 5.